Okay, we're going to simplify then factor. So why do I say that? I'm going to give it, this is some function, so this function is this, and we want to simplify the function. The reason I say we're going to simplify first is because technically we're kind of factored. You could almost think like they common factored 5x out of these two, 4x out of this, and -1 out of these two. So it's a style of factoring, but it's a complex style of factoring. So it might be easier if we simplify everything and then factor it a different way. That's why I chose those words for the title. So what I'm going to do to simplify is I'm going to distribute. We're going to distribute the values that are in front of all the brackets into all the terms inside, and then we'll collect all of our like terms. So 5x times 2 gives us 10x. 5x times -x gives us -5x squared. 4x times 2x gives us positive 8x squared. 4x times -5 gives us -20x. And -1 times -3 is -3x. And -1 times -4 is positive 4. Okay, so we got a whole bunch of terms. We're going to collect some like terms here. So I'll also order them from the variable with the greatest exponent value first. So these two are like terms. These three x values are like terms, and then that constant is kind of all by itself, that number 4. So we'll do yellows together, then greens, then blues. So, and just to make this simpler to look, actually no, we'll leave it in order it is. 5x squared plus 8x squared plus 10x minus 20x minus 3x plus 4. Highlight our values again. So the 4 is still by itself. The 3 greens are all now beside each other, and the 2 yellows are beside each other. So we'll collect these like terms. -5x plus 8x is just 3x squared. 10x minus 20x is -10x. Minus 3 is -13x. And plus 4. Oh, okay. This is a trinomial. There are 3 terms. Factoring might be a little difficult here. We can do some product sum factoring. That's where you find 2 values that multiply to what a times c is. So the a and the c, these are a, c is usually green, at least when I write it. A times c, so that's 3 times 4. That's going to give us 12. And then we need 2 values that are going to add to whatever our middle term is, which is -13. So 2 numbers that multiply to 12 and add to -13, I can give us 2 right away. If I say -1 and -12, they multiply to positive 12, a negative times a negative. And -1 and -12 together give us -13. Okay? So this is a decomposition type, this product sum. So we would decompose the middle term. In other words, we turn the middle term into these 2 values. And there's an x attached to it, so we keep that x attached. So think of it like this, 3x squared. And then we have -1x, -12x. And the reason we can do that is because -1 minus -12 is -13. So we just split that one value. We really haven't changed the equation. And now we can common factor. So we'll common factor the first 2, then common factor the last 2. So what comes out of the first 2, I can pull out x. I can really just pull out x here. So if I take x, that gives me 3x minus 1. And here, I want this x coefficient to be positive, so I'm going to take out a -4. Because -4 comes out of both, so I can -4. So -12 divided -4 is positive 3x. And positive 4 divided -4 is -1. So now that I've done that, you'll notice those 2 brackets, they're the same. So the idea is that they get common factored out. But the easiest way to really look at this is we just write the 2 brackets 3 as 1 together, so 3x minus 1. And then whatever's left over, which is the x minus 4, those are the common factored values. Those get written in the other bracket, so x minus 4. And this would actually be our final answer. So f at x, that's the original thing I wrote, is equal to 3x minus 1 times x minus 4. Again, quite a bit of factoring to this. We had to, I don't know what happened there. We had to expand all of our terms, simplify them, and then use some decomposition factoring to get down to our last term here.